Hello and welcome to this talk on automated pen testing, a better way to pen test. My name is Alex Haynes. I have a background in offensive security. I'm a former pen tester and currently an active crowdsourced pen tester and security researcher. At the time of this recording, I am currently CISO at a company called IBS Software. So today we'll be going through traditional pen testing and the challenges that abound with traditional pen testing approaches. We'll also be covering comparisons to crowdsourced pen testing and how that differs to traditional pen testing. And we'll also cover automated pen testing, which is the purpose of this talk, because it is quite new, and we'll cover how that differs to the other types of pen testing that are available on the market today. And finally, we'll finish off with the different use cases for different types of pen testing, because there are best case scenarios for certain types of pen testing, so we'll cover each one. So what is traditional pen testing today? The definition that's generally accepted is this: a snapshot of your security posture at a particular point in time. It's no longer classed as a simulation of an attack on your environment by an attacker, because it doesn't do that anymore. So this is what we refer to when we talk about traditional pen testing, and I'll explain why that is. So what are the challenges with traditional pen testing today? The first is what we call the frequency of testing approach. So 10 years ago, when companies had web applications and they published web applications externally, they didn't often update them. Typically, it was quite common to find a once-a-year update on a website or an application. Now, with pen testing done typically once a year, and today most companies still do pen testing as an annual exercise once a year, that pen test being done after an update was actually quite relevant if you only had one update a year, because it was representative of your security posture, which was maintained constantly throughout the year. Today, in today's environment, many companies have switched to monthly updates, weekly updates, daily updates, and some people are already in continuous delivery, where their website or application is constantly updated. In these kind of scenarios, pen tests and pen test reports are out of date almost as soon as the pen test is completed, because the environment has completely changed, so the report does not reflect the environment anyway. And this is what we refer to as the frequency of testing weakness of traditional pen testing, because as you update your environment, it's quite common to find new functionality that's pushed, which may potentially introduce new vulnerability, and that new vulnerability will not be picked up by the pen test. Hence why it's one of the main weaknesses of traditional pen testing today. Now, the second weakness and challenge with traditional pen testing is the time-limited nature of the pen test. This is also why we can't refer to pen tests as some kind of simulation of an attack. If you take an average-sized website today and you hire a pen testing company to pen test it for you, it may take about 5 days. 5 or 6 days is quite normal. And it's broken down like this. So the first day is typically consumed with automated scanning. The automated scanning will map out the attack surface. It will find exposed ports and services, patch versions. It may also find what we call low-hanging fruit in terms of vulnerabilities, cross-site scripting, SQL injections that automated tools can detect. That's the first day. The middle 3 days is actually the meat of the pen test. That's when the pen tester will manually try and tease out error messages and turn them into exploits. They will try and get at the data behind the asset, and is the most important and most time-consuming part of the pen test. That's why time is the constant enemy of the pen tester. They don't have time to review every single nook and cranny of your website. They're really going to go for the low-hanging fruit and what looks exploitable. This is also why it's not reflective of an attack anymore. Attackers do not spend 5 days on your website and go and write a report. They can spend weeks, months, potentially years examining your application, because they have time on their side, so time is the enemy. The last day of the pen test is typically consumed with report writing, which is essentially just writing up the pen tester's findings. And again, it won't be exhaustive, it'll be what they found. The final inadequacy is what we call the skill set approach. Now, this is not an issue with a business model of pen tester or what services pen testing companies offer. This is really a human limitation on the accumulation of knowledge, and is exacerbated by the amount of technology that companies use today. Companies use various technology stacks that have become quite complex. So if you take a scenario with company A that has an example technology stack, which includes what's listed on the slide, they'll order a pen test from a pen testing vendor, and that pen testing vendor will provide a consultant, and that consultant may or may not have expertise in various parts of that technology stack. But it is unlikely, simply because it's humanly impossible, to have exhaustive, extensive expert knowledge in every layer of that technology stack, even though most pen testers will usually muddle through and be able to find most vulnerabilities in general technology stacks. But this is a human limitation, one of the inadequacies of traditional pen testing today. So how does crowdsourced pen testing in general differ from this? So if we go back to the frequency of testing approach, it's less of an issue in crowdsourced pen testing, because crowdsourced pen testing throws as many bodies as possible at this problem. You sometimes have dozens, on rare occasions, hundreds of researchers at a single time testing something. And because crowdsourced pen tests are open-ended, they can flow in and out of the pen test at their leisure at any time. So when there's usually a new update, chances are you will have a pen tester there testing it. Again, if there's a new vulnerability released with a new functionality update, pen testers will be there to find it and report it. This is one of the main advantages of crowdsourced pen testing over traditional pen testing. In the time-limited nature of the approach, most crowdsourced pen tests, I would say well over 90%, 95%, don't have a time limit. They're actually open-ended. The shortest crowdsourced pen test I've ever been involved in or ever seen is about 2 weeks, which is usually about double the length of a standard pen test anyway. But the large majority of crowdsourced pen tests are open-ended. The advantage of this is this maps better to how attackers behave, because, like I mentioned earlier, attackers don't just spend 5 days on your website and then move on to something else. They will actually take their time. They can take 2, 3 months, 4 months, 6 months, a year if they wish, and finally dig up that esoteric, critical, hard-to-find vulnerability that will compromise your business. This is why typically, on a comparison scale, crowdsourced programs have been shown to find more critical vulnerabilities in general than traditional pen tests, because they have the advantage of time. It's not anything else. And finally, the skill set limitation. Again, it's a human problem, so how do you solve it? Well, crowdsourced solves it by throwing as many bodies as possible at a problem. When you go back to this company A with a specific technology stack and you take a group of 100 pen testers, the group is large enough that you're more likely to find this X factor, this one individual that knows and understands your technology stack perfectly, and so therefore is more likely to find vulnerabilities that have value and that are more impactful for you. Now, there are weaknesses to every approach. Crowdsourced security, like any approach in pen testing, does have its weaknesses. One is it's not necessarily cost-effective. So a traditional pen test, the main advantage is it is very cost-effective. You're paying a consultant a day rate. Now, today, at the time of presentation, this can vary from anywhere from $800 to $1,500 a day. And you pay per number of days, regardless of the number of vulnerabilities that are found. In a crowdsourced scenario, certain vendors actually make you pay per vulnerability found, and on top of a license fee for accessing these crowdsourced pen testing platforms. This can quickly become very expensive, especially if it's the first time you've done a pen test and your crowdsourced pen test turns up 50 vulnerabilities, and you're paying 50 vulnerabilities individually on top of the license fee you need to run the pen test. Generally speaking, that's why it's not a good idea to have your first pen test ever to be a crowdsourced pen test. You really want a traditional pen test to weed out these low-hanging fruits so you're not paying individually for them. The second issue with crowdsourced pen tests is the skill set that exists on the market today is generally web heavy. What I mean by that is it's very easy to learn web applications, and people can test web applications remotely. Once you start going into things like code audit, thick client, IoT, mobile applications, it's a more specialized skill set. So you'll still run into this scarcity issue that you run into with traditional pen tests, where if you want something like a thick client to be analyzed, you're going to have a hard time finding that skill set. Testing inside the network is also a challenge. If you go back to the traditional pen tests and you want someone to test inside your network, typically it's quite easy. You have a human pen tester that will turn up to your office, plug their laptop in, and then they can start pen testing your environment from the inside. In a crowdsourced environment, because the pen testers are not physically present, they're spread out all over the world, you have to set up some kind of dedicated connection for them, which is typically a VPN, some kind of proxy. Now, That would be okay if it was a single pen tester, but crowdsourced pen testers do not rely on a single pen tester. They have dozens of pen testers. Again, sometimes in rare cases, over 100. So you have to multiply this. You have to have VPN connections for all of them, proxy connections for all of them. It's an extra administrative overhead, which brings me to the last point. It also increases traffic tenfold than what you're usually used to. It's quite common, and I've seen this happen in web-based crowdsourced pen tests, for example. If a pen test has just been launched and all the testers will launch their automated scanners, scripts, automated tools all at once, and if you have 20, 30 people launching scripts on a website, it slows down and can eventually crash. So you have to be wary of this weakness and challenge and make sure your assets are robust enough to maintain that level of traffic. Likewise, if you're running 20, 30 VPN connections into your environment has to be able to manage that level of traffic. So we're on to automated pen testing. What are we talking about here? And there is generally no accepted definition, but I've attempted to create one because the tools, like I said, are quite new. And what they are is effectively a replacement to the human pen tester. These are tools or software that effectively replicate the behavior of the human pen tester, make a decision on what asset to attack, how to exploit it, and then pivot to that asset and move on to other assets autonomously. And they do this at scale across hundreds, sometimes thousands of systems. That's effectively had to define automated pen testing. This is what it is. If I were to represent it visually, this is essentially what it looks like. So on the left-hand side of the slide, you have your asset where you would start your pen test. This is typically an agent or some kind of script that's installed. And from there, you let the tool run. It will autonomously scan its own environment. The asset that it's on, it will scan the machines around it, its own subnet, for example, and then it will see if it can find any vulnerable machines. And crucially, it will attempt to exploit these. So in this scenario, it attempts to move to this server in the middle that is vulnerable to Eternal Blue. It will attempt the exploit. If successful, it will then pivot to that machine. And then it will repeat the process anew, scan the subnet or local environment. And in this case, it's found 2 more vulnerabilities. So you've got pass the hash and SSH. And then it will make a decision based on how easy it is to exploit those machines. In this event, it would probably be more likely that they would exploit the default password option. If that failed, they would fall back to pass the hash as an example. And this is exactly how a human pen tester would actually behave. They would simply pick the easiest option because humans will always go for the low-hanging fruit. Like I said, they're there to mimic a human pen tester. Human pen testers are trying to be efficient with their time. So this is how it would typically behave. Now, being an automated tool, it's quite common to make the comparison and get them confused with vulnerability scanners, which are also automated tools. So how do they really compare? So today you've got vulnerability scanners which have existed for many years. Automated pen testing tools, the main difference is they will exploit vulnerabilities. Vulnerability scanners will not. If they find a SQL injection, they may tell you that they potentially have found one. They will not exploit it and start extracting the database and attempt to create a shell or anything like that. Automated pen testing tools will. They will pivot to the machine. They will extract data to prove it, which is one of the main differences. They can also pivot. Vulnerability scanners will never pivot to another system. In terms of report writing, vulnerability scanners will simply print out a list of vulnerabilities they found. They'll list the CVE codes, the severity based on CVSS typically, and perhaps some screenshots of proof of concept, but it's very basic. Automated pen testing reports resemble human pen testing reports in the sense it will have a step-by-step guide on how they achieved an exploit, what they did, what commands were tried, what was on the system, and with extracts and screenshots of any data that was captured at the time. Both of them can be used to meet various PCI DSS requirements if implemented successfully. Keep in mind that they're different requirements. So the vulnerability scanners meet the quarterly scan requirements in PCI DSS when they're talking about vulnerability scans. Automating pen testing tools meet the pen testing requirements within PCI DSS. So they take care of different requirements, but they can be used to meet PCI DSS requirements. One of the major flaws of automated pen testing tools is they do not understand web applications currently at the time of this presentation at all. That means they will completely ignore them, even if they're found inside the network and they're completely insecure, they will ignore them completely. It's a large distinction. Vulnerability scanners especially web application scanners, actually do understand websites and they can scan them. Both of them can exist in authenticated mode. What that means is they can run as different users. If they get to an authentication portal, they can authenticate to it if you give them credentials to move on to the next layer. Now, there are cons to automated pen testing like everything else. The main advantage is they can be run continuously. You're not running a human or paying a human per day. You can actually run these tests every day if you wish, every build continuously. They generate reports on the fly, so you don't have to wait for a human to draft a pen test report, and you don't have to wait for it to go through QA. It can be generated on the fly. On top of that, because you can run it from anywhere and at any time, you can generate as many scenarios as you wish, put them on different servers to start with, to see how they would impact different parts of your environment. The downsides are, being a tool, a piece of software, it is limited to what it is programmed to do. It won't discover any 0 days for you. It won't think outside the box. Human pen testers typically do this when encountering unique technology or specific configurations. If the exploit, or if a publicly known exploit does not exist, they won't attempt one. That's very important. They also don't understand web applications. They will ignore them. So if you have web applications, it won't touch them, and it can't be used to pen test web applications. This is also why it can only be used inside your network. It cannot be used for an external pen test, because most things that are exposed on the external environment are web applications. So hence they cannot be used to do that. There is a cost element. Don't forget cost. These tools are typically licensed per server within your environment. If you have 5, 6, 7,000 servers or more, the cost can start to get quite prohibitive. Whereas a human pen tester, remember, you're paying a flat fee per day. Typically, the number of days will expand depending on the number of assets you have, but it won't expand in the same way. So this is one of the downsides of automated pen testing. And here we get to a summary table on what's the best use case for each type of pen testing. Like I said, you've got different pen testing: traditional pen testing, crowdsourced pen testing, automated pen testing. They can be used for different things, and you'll get better results if you use them on certain scenarios. If you're red teaming, for example, crowdsourced pen testing doesn't offer a red teaming option. Red teaming involving things like social engineering and physical bypasses, simulating an attack. Traditional pen testing companies still do that. Crowdsourced pen testing, for example, if you can afford it, you'd want to run it for an externally facing website. There you'd get the best result. Automated pen testing, of course, on the external website wouldn't work at all. Likewise, if you have IoT mobile devices, automated pen testing will not help you, nor will it help you if you have a web application. So it's important to remember that you have different scenarios, different use cases, and remember budget. Budget is a very important distinction. Pen testing will always be, traditional pen testing will always be the most cost-effective solution to all of this. So, come to the conclusion. Make sure you understand the differences in the approaches. Now, today, at the time of this presentation, you currently have 3 different types of pen testing available. You've got traditional, crowdsourced, and automated. They all have their pros and cons. Make sure you're aware of them. It's important to point out they're not actually mutually exclusive. You can have and start with, it's always recommended to start with a traditional pen testing program, layer a crowdsourced program on top of that, and if you wish, and budget permitting, you can actually implement automated pen testing tools on top of that. So they're not mutually exclusive. You can layer them on top of each other. Budget's very important. Again, don't start with crowdsourced pen tests, especially if you can't afford it. Always start with a traditional pen test. It is the most cost-effective and will remain the most cost-effective despite its inadequacies for some time. And lastly, but not leastly, it's really important to point out pen testing is one part of your whole defense in-depth approach. If you're just doing pen testing but ignoring things like updates, access control, encryption, etc., and just enterprise best practice from a security perspective, pen testing won't help you because you'll be provided with a list of vulnerabilities to fix. If you can't fix them, it won't serve you. It won't give you any specific advantage. So just remember, it has to be used within your ecosystem as a holistically on top of all your other security measures that exist. So that's it from me. I hope you've enjoyed this talk and you understand pen testing a little better. Thanks for your time. Thank you.